Welcome to the AI for You Cafe for live presentations around AI. Today, the speaker is Daniel Calvon Alonso. Hello, Daniel. He's the head of AI, data and robotics unit at Atos Research and Innovation. And he is the Flexi Robots project coordinator. And he will present to us today his talk on Flexi Robots, flexible robots for intelligent automation of precision agriculture operations. My name is Carmen McWilliams, and I'm the moderator and organizer of the cafe. I'm the director of the company Grassroot Arts and partner in the AI for You project. Please take notice that the session will be recorded. The recording of this live web session will be available afterwards. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. This is not necessarily the official AI for You project opinion. And as you know, this is always an interactive cafe, so great you're all there. I'm very happy you're joining today. I see you're coming in the cafe. Please write your questions to Daniel. On the right side, you find the text control panel. You see a chat and then a text control panel for questions. I will read these questions to the speaker afterwards. So welcome again. And I shortly introduce Daniel. Daniel Calvo obtained a Master of Science in Telecommunication Engineering by the University of Cantabria in 2009. He has worked for more than 10 years in research and innovation projects in the area of heterogeneous hardware, software, embedded systems, the Internet of Things, and artificial intelligence. Currently, he is the head of the Artificial Intelligence, Data and Robotics Unit in Atos Research and Innovation. So, welcome, Daniel. How are you?
Thanks so much, Carmen. Very excited to participate in this great initiative.
Great. So we are looking forward. I give you now the presenter role and you can start your presentation. One moment. I give it to you. Have it?
Okay, so you should see now my screen, right? The presentation.
Yeah.
Okay, so let's start. First of all, thanks, Carmen, for the introduction and for the invitation to participate in this great initiative. It is a pleasure for me. As Carmen has just said, my name is Daniel Calvo, and I am part of the Research and Innovation Department of Atos. And during this session, I am going to talk about FlexiRobots project that aims to develop flexible robotic solutions for the intelligent automation of precision agriculture operations.
Yes.
So during the last years, as you know, thanks to the introduction of new digital technologies like IoT, like big data, or artificial intelligence, the traditional procedures and tools used in agriculture are being radically transformed. And drones and robots are starting also to be used as an additional and powerful way to collect high quality information from the crops, and also to automate some operations within the fields, like fertilizers spreading or the harvesting itself. Nevertheless, in most of the cases, current agro-robotic systems are designed to automate very specific tasks, are very specialized, and they work in some cases even in isolation with respect to the rest of the systems, of the ICT systems that are deployed and are used in the crops, in the fields. So at the end of the day, this leads to low return of investment for the farmers when they consider the integration and deployment of these kind of technologies, and also high risks. We need to think that in this domain, a lot of people do not have specialized IT skills or training, so it is a special vertical, let's say, that we need to take into account all these aspects. If we consider that we could use fleets of smaller, flexible, heterogeneous robots instead of just large individual units, some of these challenges could be actually mitigated or improved. Why? Because at the end of the day, if we have a smaller robot, the potential safety risk is reduced, because obviously the damage that it can cause to the human operators that are working with them in the fields are not the same, neither for the physical infrastructures and the facilities that are deployed in the crops. Also, if we have a problem with one of these units that are part of swarms of fleets of robots, okay, we can actually handle the situation by replanning the task with the rest of the units that are working, instead of just having to stop the normal operation of the crop, with the consequent economic losses. They are also smaller, as I was saying, so their impact in the soil, in the field, is also, they are more respectful with the environment and with the field, with the terrain. And if we have appropriate IT tools that, okay, maybe are not completely available at this moment commercially, but it is one of the aspects where we want to innovate with the project, to handle and to supervise and to monitor the execution of the missions by these robots. They can be even supervised and controlled by a single operator or by a small group of human operators. So what the goal of the project, of FlexiRobots project, is to make multi-robot systems cost effective by implementing mission control mechanisms and enabling real economy around data in the agricultural domain. So what we want to do is to create new systems composed by multiple heterogeneous robots that are able to collaborate in order to complete complex missions, addressing the requirements from farmers that have to operate or to handle large fields or fields with difficult geographical conditions. And these systems of robots will be integrated with also as part of bigger systems, considering also the possibility to analyze data coming from the robots, to apply artificial intelligence and advanced analytics, and also integrating data or information coming from satellite images or from IoT sensors. The project has started in January of this year. It will last 36 months, and it is being coordinated by ATOS. In order to make this possible, we have a consortium composed by 16 partners from 8 different European countries, and covering multidisciplinary and complementary skills, from the development of solutions for precision agriculture operations, ground robots, aerial robots, perception for robotic systems, collection of data, management of data, processing, artificial intelligence, and data sharing, and many others. So as you can see, it's a quite powerful, quite relevant consortium. Getting a closer view to the concrete approach and objectives of the project, FlexiRobots wants to define a reference architecture and to implement the enablers to create this mission control of multi-robot systems, robots that are diverse, that are heterogeneous, that should collaborate to accomplish complex missions. the architecture will be designed also to support the secure and sovereign exchange of data following the principles of international data spaces. With this, we aim to break the data silos that we have now, because several platforms, several systems, several stakeholders are participating in the typical deployments or systems that we have in the agriculture domain. So this will open the door also to have interoperability between all of them, but also to open new business models for the farmers. We are going to develop also AI-powered models that will be embedded directly within the robots to improve their capabilities in terms of perception, in terms of navigation and decision making, or even actuation. But they will be used not just in the robots. They will use also to analyze the information coming from these robot systems, from the drones, but also from other data sources, in order to create advanced services for the needs of the farmers. In this process, we will pay special attention to be compliant with the requirements that the European Commission has established in terms of trustworthy AI, and we will try to particularize them, to provide guidelines regarding how to apply them in the agriculture domain. As I was saying, we are not going to target scenarios just with a single robot or with a group of similar robots. In our fleets, we will have drones, we will have different types of ground robots, of robotized tractors, collaborating all together in complex missions. And we will see some examples later in the project use cases. We have 3 pilots in the project, targeting also varying levels of complexity in terms of the types of the crops, in terms of weather conditions, geographical locations, and national regulations. Something very interesting, especially in the context of this AI4EU Café, is that we plan actually also to contribute to the artificial intelligence on-demand platform. How? Well, in the project, we will generate some data sets and some models, and we will study and analyze that as many as possible. They are published in the AI4EU platform, so that they can be accessible by the whole European AI community. In the process of developing these models and these components, we will analyze the ethical, legal, socio-economic issues. For instance, how to guarantee this aspect I mentioned before regarding the scalable human supervision and oversight. So we have dedicated tasks and partners in the project to do this assessment. And finally, okay, we want that the project results can be accessed by any partner in any region of Europe. So the involvement of the digital innovation hubs is going to be also quite important for the project. So in the project, we are defining this reference architecture, and we will implement also a common platform instantiating this reference architecture that will be then tailored by each one of the pilots to the specific characteristics and needs of them. So this platform is going to be composed by different layers. In the bottom part, we have the interoperability, considering already existing standards like ISOBUS, like OGC reference architectures from international data spaces, or the results of projects like Demeter or OpenDay. Then we have the core, the services that consist of the common abstractions, the functions, and the interfaces that will allow exploiting the 2 main components that we are going to develop within the project. The flexible mission control center for the multi-robot systems that I have mentioned several times during the presentation, and it's one of the core elements of the project, and the agricultural data spaces. Following we consider that the AI-driven robotics will be like a sub-capability of these agricultural data spaces, and they will comprise methods, tools, and resources to build AI models, machine learning models within the scope of these data spaces. That they will remain abstract of all the low-level robotics protocols or of other platforms that could be deployed in the fields through this interoperability layer. And we will consider also the analysis of images coming from satellites and so on. I will elaborate a bit later on this. And in the top part of the architecture of the platform, we have the services, the applications that will be built on top of these functionalities that will help developers to create new systems for precision agriculture operations using artificial intelligence and robotics. And for instance, in the project, we are going to demonstrate this with these 3 large-scale pilots. So the project, the platform in the project will consider, as I said, by design that the data owned by the farmers and by the different stakeholders, or that is generated by the different systems that we have in this domain that is generated during the creation of the operation of the applications in this domain can be actually exchanged in a safe and sovereign way, following the guidelines from IDSA, that is one of the partners of the consortium. So we plan to leverage the results of previous projects that have already worked on this domain. For instance, Atos and BTT are working in this address. And we will implement in the project what we could call like embryonic data spaces for agricultural domain. And we envision that these data spaces are going to be like an integrative element along the agricultural value chain or network, so that we can bring together all the stakeholders, that they can benefit from each other's data. So at the end of the day, if you have the capacity to share your operational data, traceability from your processes and from your products, you will be in a better position to create like the view of your processes and of your products. You will be able to apply some machine learning and artificial intelligence to optimize this process and to improve them. So this is one of the things we want to do. Again, I think that it is important to mention that the project has special dedicated tasks to work on artificial intelligence. And following the IDSA vision, we think that in general, that the analytics of the data should be addressed within the limits, within the boundaries of the data spaces, and we are going to develop services for building and optimizing some models that could be common for several applications within this kind of agricultural applications. For instance, we are considering now that we will develop some models for image segmentation, or to identify human operators, or in general moving objects within the fields, considering the images gathered by the drones or by the robots. So this is something that we are discussing right now. As I said before, we want also to contribute to the AI4EU platform. So with these 3 large-scale pilots that we have in the project, we are going to generate huge data sets with labeled information, with labeled images gathered by drones, gathered by robots. Also observations from IoT sensors in the form of time series format. So we are going to study that many of these data sets can be published in the AI4EU platform. We are going to develop also, in addition to these models that could be common for several use cases, other ones that would be more specific to the needs of each one of the pilots. For instance, to detect and identify pests or diseases in the crops, to identify objects, to predict the yield of the crop, considering information gathered by the sensors or the images from the satellite images and so on. So we will also study if these models can be published in the platform. And Asatos is also part of the I4EU project. We have some know-how about the experimentation capabilities that are offered by the platform right now. We will see if we can also exploit them for the purpose of the project and to contribute to them. So at the end of the day, my message here is that we want to achieve some level of interoperability between the I4EU and FlexiRobots platform, although it is, let's say, it is true that it's not the primary pillar of the project. In terms of satellite images and spatial analysis, we are going to use Open Data Cube technologies for managing and accessing in a distributed manner to Copernicus and other Earth observation datasets available in Dias Mundi, but also available in platforms that could be brought by the project partners. Also the images collected by the drones. We will create also some specific connectors for those data formats that are currently not supported. And the access to all this data will be done through standard interfaces that are already provided by the Open Data Cube connector component. So I think it's a good moment now to do like an overview of the project pilots, because this is an innovation action, and indeed in this sense the role of the pilots is going to be absolutely essential, because they will allow us to demonstrate the technologies that we are developing within the project in operational and realistic environments and conditions. So at the end of the project, our key exploitable assets will be mature enough to initiate the commercialization phase sooner. So we have these 3 pilots. The first one will be carried out in Spain, in the vineyard of a Spanish winery group called Terras Gauda. The vineyard is located in Galicia. It's a region in the north of Spain with an Atlantic climate, with abundant rainfall. I know this because I live also in a region in the north, and it is indeed today it is raining. The pilot will be focused on the introduction of robotic technologies in 3 different use cases that today are done mainly manually or by people with a very low level of automation, I would say. So the first one is in-person inspection of the vineyards for searching diseases. The second one is the application of phytosanitary treatment to address these diseases, and now this is done in a, let's say, indiscriminate way over the plants. And finally, the autonomous transport of the grapes to the winery. At this moment, this is done mainly combining persons and some standard machinery. So in the first case, the drones will be used for the early detection of a pest called Botrytis cinerea. That is a fungus that affects many plant species, but notably to the wine grapes. And the observation of this pest will be done using the multispectral images gathered by drones, and then we will use these images to obtain normalized difference vegetation indexes. This is a calculation done between the near infrared between the near infrared light that is reflected by the plant and the light and the visible light, and it offers a good correlation with the probability of suffering this disease at the end of the campaign. So the idea is that if we are able to automate or to plan some drones flights during key moments of the campaign, we could use this information to create like health maps that to quantify the porosity of the wines of the vineyard, and to plan some preventive actions that can be executed by the ground robots, by the swarm robots that are available in the farm. So we have in this kind of mission, in this kind of use case, two types of robots. In the first step, the drones that will have integrated some hyperspectral cameras will gather these images to create the health maps in order to identify the areas of the vineyard that could be mostly affected by this botrytis fungus. And then with this information, the ground robots, the swarm of ground robots will navigate to the areas that are more likely to be affected. They have some sensors and cameras to do a closer recognition and to confirm this hypothesis, and then to apply the treatment with a higher accuracy, minimizing also the impact in the soil and in the environment due to the random usage of these kind of pesticides. Then finally, in the final part of the campaign, let's say that the fleet of robots will be able to transport autonomously the grapes collected in the vineyard to the center of the winery. We are talking about small robots that will be able to identify the human operators, to follow them, and to navigate through the vineyard lines and to head to the winery. They will be equipped also with sensors to know the level of fill of the basket and the weight of the grapes. This data can be also used to know which areas of the vineyard are more productive and to create harvesting maps. And this is a really interesting use case in the project, because we have a very close relation and collaboration between the human operators and the robots. So in this part, we need to handle properly all the safety concerns and risks to guarantee the integrity of the human workers. So it's a very special and interesting scenario. The second pilot will be carried out in a research station in Finland, 600 kilometers north of Helsinki. So as you can imagine, here we have an additional challenge, because during more than half of the year, the weather conditions do not allow to do anything in the crops, because there is like a lot of snow. And in this case, we are going to implement 3 use cases. Again, pest control, Ramex plants weeding, and the silage harvesting. And in this case, we are talking about a pilot focus on rapeseeds. So as it happens in the Spanish pilot for the detection of the Botrytis cinerea pest, in this case, actually at this moment, the treatments are also applied indiscriminately over the plants. This is not efficient in terms of budget, but neither due to the potential environmental impact of this kind of products. So the idea is that if using the drones we are able to gather close range images from the rapeseeds, and we can combine these images with the observations of some IoT sensor IoT insect traps. We could create also maps identifying in which areas we have a problem with these small insects. Then again, as you can see, we combine the capabilities of the drones with the ground robots. So we will send some ground robots to confirm that we are suffering actually this problem, to send the images to the data center. And finally, these large robotized tractors that are currently working in the fields, in the crops, will be complemented by drones in order to do a more accurate hotspot spraying to fight against this disease. The second use case of this pilot is focused on the Ramex plant weeding. So it is quite similar. We have a mission again where in the first step the drones are going to obtain the images to produce high quality maps where we will locate the areas where we have a problem with the Ramex plants, and then the ground robots that are equipped with cameras and with sensors and with a robotic arm will navigate autonomously to these areas, will recognize that where are located the plants, the Ramex plants, and will demonstrate the autonomous removal and transportation of the weeds. So again, we are talking about a use case that um, needs this orchestration of two different types of versatile robots. In the last use case of this pilot, we are targeting silage harvesting. So here we are going to consider the images gathered by satellites, also combined with information from the IoT sensors, and with this we will create some maps about the status of the fields. We will obtain harvesting forecasts considering this information, so that we can optimize the harvesting process that is done with these ISOBUS compliant robotized tractors. And we are going to, in order to mitigate some of the risks of having these large vehicles, what we are going to do also is to implement a situational awareness in order to understand what is happening in the field, where are located these robots, how they are moving, and we will complement the information that they are able to provide with also with images from drones in near real time. We will identify the tractors with the images from the drones, so that we are able to detect possible hazardous situations. The third pilot and the last one is focused on the production of blueberries, and it is actually split between two countries, Serbia and Lithuania. And the idea of having a pilot with the same type of product in two different countries is to demonstrate the scalability, the reusability, and reproducibility of the solution in a relatively similar conditions, but with different technologies and with different stakeholders. In this case, we are going to implement 4 different use cases focused on monitoring of the crops, automated field soil sampling and analysis, disease detection again, and again the autonomous agrichemical spraying. So in the first case, we are not using robots at all, but we are using we are gathering some information from the crops, from the sensors, and we will apply some machine learning models in order to obtain forecasts regarding important parameters for the decision-making process, and that will be used later by the robotic systems in the other use cases. The second part is focused on the automated field soil sampling. So we are integrating soil sensor that has been produced by one of the partners of the consortium, but by Biosense, in one of these robots. And we will obtain georeference data in a high resolution time frame that will support also the decision making process, creating like these maps where we will also fuse the images coming from the drones. And in the third step, we will also use some aerial vehicles in order to detect pests, weeds, and diseases that obviously are also a problem for blueberries. So as you can see, it is a similar use case to the ones we have in Spain and also in Finland. So we will collect the multispectral images. We will calculate the normalized difference vegetation indexes. We will use some deep learning models to identify the weeds and the diseases and so on. And finally, also we are talking about how to use all this information, the outcomes of all these use cases to perform, to apply the appropriate treatment in the field using some fleets of ground robots that will be equipped with cameras, with sensors to detect locally the weeds and the diseases and to apply the spraying itself. So what we want to achieve with the project, the impact what we want to have is to demonstrate that the possibilities of robotic systems when they are integrated with the rest of the technologies we have so far available in the fields, when they are operating with for over extended periods of time and in complex conditions. So having this kind of fleets of robots, of versatile and small robots, we think that is going to suppose a great innovation with respect to the state of the art. We will try to reduce also the safety risks and not only the safety risks, but also some of the concerns and the challenges that actually are avoiding the the definite adoption of these technologies within the fields. We will target also some open standards and factor standards. So at the end of the day, what we want to do is to improve the level of competitiveness of the European agricultural market and the European companies. So that's all from my side. I have tried to provide like an overall view of what we want to do, because it is true that the project is actually in the early phase. As I said, it has begun in January of this year, but I hope that you had now a better understanding of what we intend to do, of our objectives, of our pilots, technologies. And of course, now I am more than happy to try to answer some of your questions.
Yes, thank you very much, Daniel. It was really interesting. I have the first question, and then we get the participants to ask you questions. Yes, I'm interested about this grape pilot, because my grandfather was a winemaker long time ago. And we are in Germany, and there are hills, hills, very steep hills, and we make white wine on. Do you think there can be a robot in the future who can handle these hills?
Well, it depends on the terrain, so it's something that should be analyzed, taking into account the specific characteristics of its type of field. But I think so. I think so. I think that the robotic systems are evolving in the last years, and we are seeing some already existing examples, even in some of these EU-funded projects. So I think so. I am positive about this.
Yes, because this is really, I mean, if there would be ever a robot capable of picking the grapes in the hills, this would be fantastic.
Yeah,
So,
yeah. In our project, I don't think that we have a use case where the robots actually pick the grapes. So we are not so ambitious in this point. But I am aware that there are some already existing robotic solutions that are able to pick, for instance, strawberries with a high level of accuracy and without causing damage to the product. So I think that we are progressing.
okay. So now comes the questions from the audience, and here it's the first question is from Moemit Kuma Ahua. Are the data sets made public?
We have not started yet the collection of data sets, let's say, although some of the partners have some already existing information due to previous projects or due to their operational equipment and installations and so on. The campaign for the data collection will start mainly during this summer, during the first year of the project. Especially in the case of Finland, this must be done mandatory during the summer, because during the winter we will have like 3 meters of snow in the fields. But actually, it's our idea. Our idea is to study that many of these data sets can be made available, and possibly through the AI4EU platform.
Okay, great. And here comes Elliot Dixon. His question is any effort being made to use the same software and hardware platforms for all the pilots?
Actually, no. Actually, we are not at the hardware level, let's say. We understand that the agriculture domain is very heterogeneous, that there are different needs depending on the type of crop, on the type of product that we are targeting. So this is an innovation action project. We need to be very close to the real world, let's say. And what we want to achieve is a high level of interoperability and compatibility with these solutions. At the, let's say, the AI platform level and the AI modules, we are trying to see if we can find some similarities between all the pilots and to propose something that must be that can be more or less common to all of them.
Okay, thank you. And now, I hope the name is what I'm saying now is right. Fredrik Yuma. His question is, are there any robots that can inspect fish in the cages, count number of fish, check of health of fish, and help in the repair of nets underwater? This is a question from a fish farmer.
I guess so. To be honest, I am not an expert in in robots being used in the fish environment, so I am sorry I cannot answer. But we can check this. Maybe okay, it could be a nice project for the future. Who knows?
Yes, and yes, also, I mean, it continues. The question is, are there any, I mean, do you have any water drones to monitor water quality? That's also from Fredrik.
Indeed, I know some Spanish SMEs working here in Cantabria, in the University of Cantabria, that are developing underwater drones to obtain images from the environment, to detect pollution, also for the inspection of the ships and ports. I have contacts with them, so if this person wants to have their contact, I can provide it.
So Frederick, I hope you're still there. You also gave us your email. I see that you sent me your email. Why don't you, after this cafe session, just get in contact with Daniel, and maybe you will find out more. Now, Hamid Bouharia, what's the rationale for choosing AI for you in particular?
Why? Okay, this is a strong investment for the European Commission to join together all the AI community in Europe. You know, in Europe we are very strong in AI, in the academy, in the university, but we are not. Let's say we don't have a joint vision. We didn't have a joint vision. We were like, you know, fragmented somehow. So the European Union and the Commission is doing a strong investment, and they have the ambition to join us. And why not? Why not to support this initiative? I think that we can contribute, especially from the industry. We have from the European industry, because in my case, Atos is an European company. We have also the responsibility to contribute to this initiative.
Okay, thank you. And now Marcos Perez. Hi, thanks, Daniel. Most of the pilots are there to identify diseases. Is there any pilot plan to identify when fruits are ready to be collected? For example, right level of maturity, etc.
Okay, yeah. In the three pilots, there are use cases around the identification of pests. This is totally right, because it's one of the concerns that the end users we have in the project actually express when they join this initiative. But for instance, in the case of the blueberries pilot, and also I think in the rapeseeds one, we are going also to use the information from the IoT sensors and from the satellite images to try to select the best moment to do the harvesting itself. If I remember correctly, I have talked about the silage harvesting of the for the Finnish pilot. So yeah, it is also part of the project.
Okay, thank you. And now Mohamed Kumar Ahua. You said you will use AI in these robots for decision making. So are you considering the reliability testing of the decisions made by the robot, as the decision can be biased based on weather?
Well, this is a good question. As I said, we are still at the beginning of the project, but for sure this is something that we will need to analyze and to consider when we actually verify the capabilities of the AI models that we are going to embed in the robots. So it's something that we will need to consider when we actually deploy all these functionalities in the use cases, right?
Yes. And Camilo Correa. Hello, very interesting presentation. You mentioned that in the wine grape pilot, there will be a close interaction between human and robots, both present at once during operation. I was wondering if you shed some light on how and if you envision to enable communication and feedback from the robots to the humans and vice versa at runtime. So how do they communicate?
At this moment, we are not considering communication between the human workers and the robots that are going to somehow be working with them. It is more that the robots will be able to autonomously identify who is the worker they must follow, and once the basket is filled, they will be able to autonomously go to the central building of the winery to transport the grapes. But we don't see in our project this communication between the robots and the operators. But maybe it's something that we will incorporate. I don't know. I am not sure. But initially, we are not considering it.
Okay, thank you. So also thank you from Frederick Yuma. He will contact you. and he appreciates the SME contact. So he will, and also Camilla says thank you. So we are coming to the end. The questions are asked. I have my last question, and then we are ending the cafe for today. It was really interesting. Just as this is an interesting field, and you mentioned before also another SME, how you think we can get more SMEs involved in developing, using testing, AI and robotics? You have any idea?
Yes, indeed, it is something that we are targeting from my research team in many projects. So at the end of the day, we think that in many cases, okay, when you are developing AI systems, especially for SMEs or small startups, it is not always possible to have access to really complex hardware infrastructures or to have very specialized people with a lot of machine learning knowledge and data analytics and so on. So we need to develop some tools, some mechanisms that reduce the complexity for handling all these processes that allows them to develop some models on top of solutions that are already there as a service, or even to retrain some models that are already available that have a good accuracy using some transfer learning mechanisms and so on. So I think that we need to, from the industry and also probably the institutions, need to invest in this sense. And the other aspect is probably industrial data. We need data actually to train all these models in the industrial world. And this is something that probably is not happening at this moment with a required level of quality and volume. So it's another point that must be improved.
Yes, thank you. Because I need an SME who develops this robot who climbs up the hills and picks the grapes. So we have to. So anyway, thank you very much, and it was a pleasure to have you here. Also, the audience says thanks for the interesting talk, and I will say goodbye for today and thank you, and I will send you the recording, and if you agree then we publish it on the AI for You YouTube channel. Okay, bye-bye.
Okay. Thanks so much. Bye-bye.
Bye-bye. Thank you.